This video explains how to learn any programming language fast without feeling like everything starts from zero each time. Many beginners get stuck because programming feels like memorizing syntax, but the truth is simple. Programming is one skill, and languages are different ways to write it. By the end, it will be clear what to learn first, how to switch languages faster, and how to choose the right language for the job. Let's begin. Before learning multiple languages, build a universal core. This is the part of programming that exists in every language. No matter which language is used, Python, JavaScript, C#, Java, Go, these concepts remain the same. Variables and data types, operators, control flow like if statements and loops, functions, data structures like lists and dictionaries, error handling, code organization using modules or packages, basic OOP with classes and objects, and later advanced ideas like memory and execution. Once these concepts are solid, learning a new language becomes much easier because programming is already understood and only the syntax changes. Next, choose one language as a home base. For most beginners, Python works very well. Python has clean syntax and less boilerplate, which helps learners focus on logic instead of rules. A simple learning flow works best. Explain the idea, show a tiny example, do a quick exercise, then build a mini project. This builds confidence in one consistent environment before switching languages. After choosing one home-based language, the next step is to understand what that language actually covers. Here's what mastering Python really means. Start with variables and types. A variable stores data, and each value has a type. In Python, types like string, integer, float, boolean, and none are simple and readable. The syntax is clean. There is no need to declare types explicitly, which helps beginners focus on logic instead of strict rules. Next are operators. Operators allow calculation and comparison. Addition, subtraction, multiplication, division, and logical comparisons are fundamental in every programming language. Once these are understood in Python, they can be recognized easily in other languages. Control flow comes next. This includes if statements for loops and while loops. These control how the program moves and repeats tasks. The structure in Python is extremely readable because indentation defines the block. This makes the logic visually clear. Then functions. A function groups logic into reusable blocks. Instead of repeating code, logic is wrapped inside a function and called when needed. This is one of the most important ideas in programming because it teaches modular thinking. Data structures follow. Lists store ordered items. Dictionaries store key value pairs. Sets store unique values. These structures allow programs to organize and manipulate data efficiently. Every language has its own version of these, even if the syntax changes. After that comes error handling. Programs must handle unexpected situations. In Python, try and accept blocks prevent crashes and allow graceful handling of errors. This introduces defensive programming. Modules are next. Code can be separated into files and reused. Importing built-in modules like math shows how programs grow beyond a single file. This introduces the idea of code organization and scalability. Then object-oriented programming. Classes define blueprints for objects. Objects hold data and behavior together. Creating a person class shows how real-world concepts can be modeled in code. This prepares learners for structured software design. Finally, memory behavior. When one variable references another object, changes can affect both. Understanding how references work prevents subtle bugs. This is where deeper understanding begins. At this point, something important happens. After going through variables, operators, control flow, functions, data structures, error handling, modules, OOP, and memory behavior, programming is no longer mysterious. The fundamentals are now internalized. And this is exactly why a home-based language is powerful. Because once these ideas are clear in one language, switching to another language does not mean starting over. It simply means expressing the same ideas differently. And that leads directly into the next step. Translation instead of relearning. The key to learning languages fast is translation, not relearning. Instead of learning JavaScript from scratch, the focus becomes translating known ideas into new syntax. Same logic, same problem, different syntax. For example, once the concept of a function is understood, a new language only requires one question. How does this language write a function? Concepts stay the same, only expression changes. This removes fear and makes switching languages feel natural. Now let's see what translation really looks like in practice. Start with something simple, variables. In Python, creating a variable is very direct. A name is connected to a value. The language automatically understands the type. If the value is a number, it treats it as an integer. If it's text, it treats it as a string. There is no need to declare the type explicitly. This is called dynamic typing. Now compare that with JavaScript. In JavaScript, a keyword such as let is used before the variable name. The value is still attached to the name, but the language requires a small amount of extra structure. Even so, the concept remains identical. A variable still stores data. Now look at C#. In C#, the type must be declared first. The program must clearly state whether the data is an integer or a string. This is called static typing. The compiler checks types before the program runs. So what actually changed? Not the concept. A variable still represents stored data. The difference is how strictly the language enforces type information. Python emphasizes simplicity and readability. JavaScript emphasizes flexibility. C# emphasizes safety and structure. This is translation. Once the idea of storing data in a variable is understood, the rest is simply learning how each language expresses it. The logic stays the same. Next, let's move to decision-making with conditional statements. Now let's move from storing data to making decisions. Decision-making is one of the most important parts of programming. Programs must choose what to do based on conditions. In Python, the structure is very readable. The condition is written after the word if, followed by a colon. Indentation defines the block of code that runs when the condition is true. If the condition is not met, the else block runs instead. Now look at JavaScript. The logic is identical. There is still an if and an else. But JavaScript uses parentheses around the condition and curly braces to define the block. It also uses semicolons at the end of statements. The structure looks slightly more formal, but the idea remains exactly the same. Now look at C#. Again, the pattern is familiar. Parentheses around the condition, curly braces around the code block, strong typing for the variable, and structured output statements? So what changed? Not the logic. The program still checks whether a person is an adult or a minor based on age. The comparison is the same. The decision flow is the same. The difference lies only in syntax rules. Python uses indentation. JavaScript uses braces and is dynamically typed. C# uses braces and is statically typed. This is translation in practice. Once the concept of conditional logic is understood, switching languages becomes an exercise in recognizing patterns. The thinking does not restart. Only the grammar changes. Next, let's look at repetition with loops. Now let's look at repetition. Loops allow a program to repeat actions. Instead of writing the same instruction multiple times, a loop handles repetition automatically. In Python, the structure is very readable. The phrase for I in range 3 means the loop will run 3 times. Indentation defines the block of code that repeats. The syntax looks almost like natural language. Now compare that with JavaScript. The logic is the same. The loop still runs 3 times. But JavaScript uses a more structured format. It includes initialization, a condition, and an increment inside parentheses. Curly braces define the block. It may look more complex at first, but it expresses the same idea. Now look at C#. Again, the pattern is familiar. Initialization, condition, and increment are written inside parentheses. Curly braces define the block. Strong typing appears in the loop variable declaration. So what changed? Not the concept. The program still repeats an action 3 times. The loop counter still increases step by step. The output remains the same. Next, let's move to functions, reusable blocks of logic. Now let's move to reusable logic. A function is simply a named block of code that performs a task. In Python, the keyword def introduces a function. The parameters are listed inside parentheses. Indentation defines the function body. The word return sends a value back. Very clean. Very readable. Now look at JavaScript. The structure is slightly more explicit. The keyword function introduces it. Curly braces define the body. A semicolon ends statements. But the idea is identical. Two inputs go in. A result comes out. Now examine C#. Here the language becomes more formal. A return type appears before the function name. Parameter types are also declared. Curly braces define the block. It looks more structured, but the core logic remains unchanged. So what is happening here? The concept never changed. A function receives input, performs logic, returns output. That pattern exists in every language. Python hides type details for simplicity. JavaScript offers flexibility. C# enforces explicit structure. But the mental model stays the same. Next, let's explore data structures, lists, and arrays, and see how they translate across languages. Now let's talk about collections. In almost every language, we need a way to store multiple values together. In Python, this structure is called a list. Square brackets create it. The append method adds a new item. Printing shows the updated collection. Simple and readable. Now look at JavaScript. The structure looks almost identical. Square brackets again. The push method adds a new value. Console logging displays the result. Different method name, same concept. Now observe C#. Here the structure is more explicit. A list of integers is created. The add method inserts a new item. String join is used for formatted output. More formal, more typed, but conceptually identical across all three languages. A collection holds multiple values. Items can be added. The structure can be printed or displayed. Python emphasizes simplicity. JavaScript emphasizes flexibility. C# emphasizes type safety. But the mental model never changes. Next, let's look at how classes translate across languages. Now let's move to object-oriented thinking. This is where many learners feel things become complicated, but again, we are not relearning. We are translating. In Python, a class defines a blueprint. Inside the class, the initializer prepares the object. The instance stores data like a name. A method performs an action. An object is created from the class. Then the method is called. Simple, clean, very readable. Now look at JavaScript. The structure looks different, but the idea is identical. There is a class. There is a constructor instead of an initializer. There is a method. An object is created using the new keyword. Then the method runs. Different keywords. Same architecture. Now observe C#. More explicit. More formal. Fields have types. Access modifiers are written. The constructor sets up the object. Methods define behavior. It may look heavier, but conceptually nothing changed. Across all three languages, a class is a blueprint. A constructor prepares the object. Data is stored inside the object. Methods define behavior. An instance is created. A method is invoked. Python hides complexity. JavaScript balances flexibility and structure. C# emphasizes strict type safety and clarity. But the mental model remains constant. Once you understand what a class represents, switching syntax becomes decoding, not relearning. This is exactly what teaching translation means. Next, we zoom out and group languages by family so learners see structure instead of chaos. To speed things up even more, avoid learning dozens of languages one by one. Group them into language families. Many languages share the same shape. First, the C-like family. This includes C, C++, C#, Java, JavaScript, and Go. These languages usually use curly braces to define blocks. They often end statements with semicolons, and their for-loop structure looks very similar across languages. If you understand one of them, the others feel familiar because the visual structure of the code stays consistent. Next, the Python-like dynamic family. This includes Python and Ruby. These languages focus on clean syntax and readability. They do not use curly braces for blocks. Instead, they rely on indentation. The code often feels closer to natural language. The philosophy here prioritizes developer clarity and productivity. Now look at the systems-oriented family. This includes C, C++, and Rust. These languages emphasize performance, strong typing, and awareness of memory. They are commonly used when speed, control, and efficiency matter. The syntax may feel stricter, but that strictness exists for a reason. Finally, the scripting family. This includes languages like Bash and PowerShell. These are command-driven and automation-focused. They are often used for system tasks, deployment scripts, and quick automation workflows. The structure is simpler, but the power comes from controlling the environment efficiently. The important lesson here is this. Languages cluster around patterns. When you learn the pattern of a family, you can move within that family much faster. Instead of memorizing every new syntax rule, recognize the structure behind it. That is how developers learn languages strategically, not randomly. Programming improves fastest through projects, not memorization. Every core concept should become a mini project. Variables and operators can become a simple calculator. If statements and loops can become a number guessing game. Data structures can become a to-do list. OOP can become a simple bank account system. File handling can become a file organizer. Web basics can become a simple API. Then comes a powerful step. Build a project in Python, then rebuild the same project in another language like JavaScript or C#. Same project, same logic, different syntax. That locks in understanding and builds real confidence. For example, let's see the sample project. A simple calculator is a great example because it looks small, but it touches the essentials: input, variables, condition checks, functions, and output. On the left is the sample output. The program asks for an operation, then asks for two numbers, then prints the result. That behavior is the goal. The behavior is what stays constant, even when the language changes. In Python, the code stays compact and readable. The functions for add, subtract, multiply, and divide are short. User input is straightforward. The main logic checks the selected operation and calls the correct function. The divide case also shows a practical safety check to prevent dividing by zero. Now look at JavaScript. The calculator behaves the same way, but the surrounding code looks bigger. That's not because the math is harder. It's because the environment is different. To accept terminal input, JavaScript uses a runtime interface for reading from standard input. Once input is available, the rest of the logic is familiar. Define the same operations, choose based on the operator, and print the result. This is the key lesson from project-based learning. The algorithm did not change. The steps did not change. Only the language and the environment changed. And that naturally raises the next question. If the goal is the same, why does the code look so different across languages? That's where constraints come in. Different languages optimize for different priorities and different environments, and those constraints explain the differences learners see. At this stage, a common question appears. Why are programming languages so different? The answer is constraints. Languages are built under different design goals and trade-offs, such as performance and hardware control, developer productivity and simplicity, safety and reliability, platform needs like web or mobile, scalability and concurrency, and ecosystem and industry demand. This changes how differences are explained. Instead of Rust is complicated, it becomes Rust is strict because it prioritizes performance and memory safety. Instead of Python is slow, it becomes Python prioritizes readability and speed of development, trading raw performance. Once constraints are understood, languages stop feeling confusing and start feeling logical. Finally, turn learning into a repeatable system by using a language learning checklist. When starting a new language, ask these questions. How are variables declared? How does typing work, static or dynamic? How are if statements and loops written? How are functions defined? What are the main data structures? How does error handling work? How is code organized using modules or packages? How does OOP work here? How are libraries installed? And how are programs run and built? This replaces confusion with a clear process. A new language becomes not a mystery and not a reset, but structured translation. One mindset shift makes everything easier. The beginner mindset asks, what language should be learned? The developer mindset asks, what problem needs solving and what constraints matter? That shift prevents language chasing and builds real skill. Here's the full roadmap. Learn the universal core, master one home-based language like Python, practice translation to other languages, learn by building projects, understand constraints and trade-offs, and use the checklist to learn new languages faster. To learn any programming language fast, avoid random syntax memorization. Learn the core once, build projects, translate concepts, understand trade-offs, and follow a checklist. That's how developers switch languages confidently. Thanks for watching and see you in the next lesson.